Okay, so today we are going to talk about number 13. A couple notes in regards to number 13. So this is a calculator. There's a lot of it's a calculator problem. So of course it requires a graphing calculator. In class, we specifically went over this type of problem. So I don't want to go over the exact how to use the calculator here. So if you have questions about how to use your calculator, either see me or obviously, there's lots of videos on, YouTube showing you how to use it. But it just slows things down for me to go through here and show you how to do it here. And again, it's not even, my calculator's a bit different. There's just issues with it. Okay, so again, I won't be showing how to use the calculator here. So let's see what we can do here. So in this question, we have this amusement park, right? Where we have people going in, right? And then people going out, right? So entering and leaving. Now, I want to emphasize, this is a rate of change. This represents the velocity of people going in. This represents the velocity of people leaving, right? So if I plug in a number into this, right? Like let's say I plug in 7, that would tell me that time, 7, which in this regards is, notice it goes from 9 to 23, but whatever. If I plug in 7 into this thing, or I guess I wouldn't plug in 7. It'd be from 9 to 23. So if I plug in, 12 into this function, then it'd tell me at time 12, this is the rate of change of people going in. This is the velocity of kind of the people going in. So, maybe there's like 20 people per hour going in or 1,000 people per hour going in. It doesn't produce a position. Same thing with LOT, okay? So that being said, let's just take a couple notes here. As I said, from time 9 to 23, these functions are good for that time, where t is the time after midnight. Okay, and we also know that at time t equals 9, there's no people in the park. So question 1, how many people have entered the park by 5 p.m., which is t equals 17? Okay, so they're asking how many people have entered the park at time 17, right? So in other words, I think you guys would agree, that's just going to be the displacement from the time the park opens, which is 9, to 17 of this. It's just how many people have entered, right? This is. So I think you guys would agree, at time 9, there's 0 people in the park, and then 17. So we're looking at the displacement, how many people have come in, and that's going to be that. And they're asking us from here, we just plug this into our calculator. Your calculators can deal with this. So I get this. Boom. Which, of course, rounds to, because they want us to do it to the nearest, I guess these would be approximation symbols, but they want us to do this to the nearest person. So this would be approximately, I think you guys would agree, 6,000 for, people. That's how many people have entered. Okay? Next, the price of admission to the park is $15 until 5 p.m. Then after 5 p.m., right, it decreases to 11 p.m. And they're asking how many dollars are collected on any given day. So I think you guys would agree. It's kind of the same idea. So think about what we're going to do. We're going to take the number of people who enter up until time 5 p.m., multiply that by $15. That will give us the number, how much money is made by those people. And then we're going to add to that, the people after 5 p.m. So in other words, I'm going to take how much each ticket cost up to 5 p.m. and I'm going to see how many people entered. Now, we actually know that number and we could use it. That would be fine. This is going to be a little bit more accurate. AP actually does accept either. I did check. So you could use this number before, just multiply by 15. That would give us the number, how much money was made for people up to 5 p.m. But again, this is a little bit more accurate. And you can do it on your calculator anyway. And then we're going to add to that 11 plus, now we're going from 17 to when it closes, which I believe is 11 p.m., so 23. Okay? From there, we are going to get our total is 104,048.165, which I think you guys would agree is going to be approximately, they want, I think, to the nearest dollar. So 104,048 Okay, moving on to part C. That's kind of weird. I think that got moved down a little bit. Let's fix that a little bit. Okay, what do we got? So we have this new function, h of t, and it equals, these two functions. So from 9 to 23, they want us to find a couple things. They want us to find h of 17. Oh, no, I'm sorry. They tell us that h of 17 is 3725, and they want us to find h prime of 17 and then kind of give what they mean in the context of each problem. So let's start with, I'm just going to go and find, let's go and find h prime of 17. So I think you guys would agree, first off, h prime of t, right? I'm going to have to take the derivative first, is going to be equal to the derivative of this function. So it's going to be equal to e of t minus L of t. Okay? From there, I'm going to evaluate this at 17. So h prime of 17 is going to be the e function evaluated at 17 minus the L function evaluated at 17. Plugging that into my calculator, again, our calculators can solve that fine, I get this. Okay? Also, think what you did, okay? Think about your units here, right? So in this case, what we base, if you think about your units, if this represents, think about what this represents in the context of this problem. This is a position function, right? Because we are integrating two rate of change functions. So this is going to give us the total number of people in the park at any one time. But now, since we're taking the derivative of that, it's going to be the change in the number of people per hour in the park. So we can say people per hour. So let's kind of revisit that a little bit. So let's talk about what both of these two things mean again. So one more time. What is h of 17? H of 17 is at time t equals 17, right? So this represents how many people are in the park at any one time. Okay? Remember, this is going to give us a position. We have people entering, we have people leaving, right? So if we take a snapshot at any specific time, like t equals 17, this gives us how many people are in the park given these two situations at this time. So at time t equals 17, there are, what they said, 3,725 people in the park. Now, let's talk about the derivative. So h prime of 17, right? Now we're looking at the rate of change of this function. So if this was the number of people, now this is the rate of change. So in this case, right, what does it tell us? And be specific. Don't just say rate of change. So what I'm going to say is that time t equals 17, right? We're going to have to analyze this number. So at time t equals 17, the number of people is in the park, I guess in the park, sure, in the park is decreasing, right? I'm talking about that negative, that's important, is decreasing at a rate of 380. I don't know, did they ask us to round or anything like that? I don't think they did. So I don't know, I don't have the question quite in front of me. Well, I do. But I'm going to keep it as a decimal because I don't think they asked us to round. I don't know if it matters. 380 people, 380.21 people per hour, right? So it's decreasing. Again, it's decreasing because the sign was negative. Let's move on to letter D. At what time does the model predict when we're at a maximum? So again, our model, right, the model that they gave us, and I'll just kind of grab this again. This is, sorry, I'm trying to grab this for you guys. So this is our model, and they want to know when is this at a maximum. So of course we take the derivative of this. So this is at a maximum when we take the derivative, And what is it about the derivative, right? Oh, when the derivative equals 0. Again, this is a calculator question. Your calculator can solve that. So I get it happens either at t equals 15.794 or t equals 15.795. Okay, I will see you in the next video.